Linux and Fundamentals Part 5. This episode has 17 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is a service mesh? Here's a strong way to approach it. A service mesh is an infrastructure layer that manages communication between microservices inside a cluster, handling things like traffic routing, security, and observability without changing application code. Especially in systems like Kubernetes core idea, a service mesh controls how services talk to each other, not what the services do. It adds a dedicated network layer for service-to-service communication, traffic control, security monitoring. Why service mesh is needed in microservices architectures. Dozens or hundreds of services communicate. Each service needs retries, logging, security, metrics. Adding this logic in every app is complex and error-prone. Service mesh solves this by moving networking logic out of application code, managing it centrally at infrastructure level. How it works. High level. A service mesh introduces two main components. 1. Data plane runs next to each service, often as a sidecar container. Example: Envoy proxy handles actual traffic between services. 2. Control plane configures and manages the proxies, defines policies, routing, security, telemetry, traffic flow. Service A sidecar proxy service B. Key features: 1. Traffic management, load balancing, traffic splitting, canary deployments, circuit breaking, retries and timeouts. 2. Security, MTLS, mutual TLS encryption, service identity authentication, zero trust networking. 3. Observability metrics, latency, errors, throughput, distributed tracing, logs between services. Popular service mesh tools: IceGeo, Linkerd, Console Connect, AWS App Mesh. Service mesh versus Kubernetes networking feature. Kubernetes basic service mesh, traffic control, basic service routing, advanced retries, canary, A or B testing, security, limited MTLS, identity-based observability, basic logs, full tracing plus metrics, complexity low. Higher. Simple analogy: think of a city. Services equals buildings, Kubernetes networking equals roads, service mesh equals traffic control system with police, signals, and cameras managing all movement. When to use service mesh. Large microservices architectures need for advanced traffic control, strong security requirements, zero trust, complex observability needs. Downsides: added complexity, performance overhead, extra proxy layer, operational learning curve. Interview ready definition: a service mesh is an infrastructure layer that manages service-to-service communication in microservices architectures, providing features like traffic routing, security, MTLS, load balancing, and observability through sidecar proxies and a centralized control plane without requiring changes to application code. Nice. Let's continue. Question 2. How does IceGeo work as a service mesh? What is the basic request or traffic flow? Here's a strong way to approach it. IceGeo injects a sidecar Envoy proxy into every pod, and all inbound or outbound traffic for that pod is transparently routed through its sidecar rather than going directly between application containers. The control plane. IceGeo pushes routing rules, MTLS certificates, and policy configuration to every sidecar. So when service A calls service B, the request actually goes app A to sidecar B to app B, with the sidecars handling encryption, retries, load balancing, and telemetry along the way, all without the application code being aware of it. Great. Moving on. Question 3. What is observability? Here's a strong way to approach it. Observability is the ability to understand a system's internal state from external signals such as logs, metrics, traces, and events. It helps teams debug unknown issues, not just monitor known failures. Detailed interview explanation. Observability is part of production observability and monitoring. Observability helps teams understand what is happening inside complex systems using metrics, logs, traces, events, profiles, and alerts. The goal is not just collecting data. The goal is detecting user impact quickly and reducing time to diagnose and recover. Production example. For a Kubernetes microservice, a good observability setup collects request rate, error rate, latency, saturation, pod health, node health, logs with correlation IDs, and distributed traces across dependencies. Alerts are usually tied to slows or error budget burn instead of every low-level metric spike. Best practices to mention. Define SLIs and slows for important user journeys. Use structured logs and propagate trace IDs or correlation IDs. Alert on actionable user impact, not noisy symptoms. Control cost with sampling. Retention policies. And cardinality limits. Attach runbooks, dashboards, and ownership to important alerts. Common interview follow-ups. Expect questions about alert fatigue. Page 95 versus page 99 latency. High cardinality metrics. Log retention. Trace sampling. RCA. MTTA, MTTR, and how observability changes for Kubernetes or ML systems. Alright, next question. Question 4. What is the difference between SLA, SLI, and slow? Here's a strong way to approach it. An SLI, service level indicator, is a measured metric like latency or availability, and slow, service level objective, is the internal target for that metric, e.g. 99.9% uptime, and SLA, service level agreement, is the external, often contractual, commitment to customers, usually with penalties if missed. Let's keep going. Question 5. What is an error budget? Here's a strong way to approach it. An error budget is the allowed amount of unreliability, 100% minus the slow a service can spend before teams must pause feature releases and prioritize reliability work instead. On to the next one. Question 6. What is a runbook? Here's a strong way to approach it. A runbook is a documented, step-by-step procedure for diagnosing and resolving a specific operational issue, used during incidents so response doesn't depend on one person's memory. Good. Here's another one. Question 7. What is version control? Here's a strong way to approach it. Version control is a system, like Git, that tracks changes to files over time, letting multiple people collaborate, review history, branch, and revert changes safely. Nice. Let's continue. Question 8. What is a Git branch? Here's a strong way to approach it. A Git branch is an independent line of development, a movable pointer to a commit, that lets you work on changes in isolation from the main code base until they're ready to merge. Great. Moving on. Question 9. What is a Git merge conflict? Here's a strong way to approach it. A merge conflict happens when Git can't automatically reconcile changes because two branches modified the same lines of a file differently, requiring a human to manually choose or combine the correct result. Alright, next question. Question 10. What is Git stash? Here's a strong way to approach it. Git stash temporarily saves your uncommitted changes, staged and unstitched onto a stack and reverts your working directory to a clean state, so you can switch branches or pull updates and later reapply those changes with Git stash pop. Let's keep going. Question 11. What is the difference between Git fetch and Git pull? Here's a strong way to approach it. Git fetch downloads new commits and branches from the remote into your local repository without touching your working directory or current branch. Git pull does a fetch and then immediately merges, or rebases, the fetched changes into your current branch. Fetch is the safe, look before you merge option. On to the next one. Question 12. What is Git cherry pick used for? Here's a strong way to approach it. Git cherry pick applies a specific commit from one branch onto another branch without merging the entire branch history. Useful for porting a single bug fix to a release branch without pulling in unrelated changes. Good. Here's another one. Question 13. What is Git squash? Here's a strong way to approach it. Squashing combines multiple sequential commits into a single commit, typically via interactive rebase, Git rebase I, used to clean up a messy work-in-progress history into one meaningful commit before merging. Nice. Let's continue. Question 14. What is Jenkins? Here's a strong way to approach it. Jenkins is a widely used open-source, self-hosted automation server for building CI or CD pipelines. It runs builds, tests, and deployments based on triggers, commits, schedules, webhooks, extended through a large plugin ecosystem. Great. Moving on. Question 15. What is Puppet, and how does it compare to Ansible? Here's a strong way to approach it. Puppet is a configuration management tool that uses a declarative, agent-based, pull model. Agents installed on each managed node periodically check in with the central Puppet master and pull their configuration, whereas Ansible is agentless and push-based over SSH. Puppet suits large, stable fleets needing continuous self-correcting enforcement, while Ansible is simpler to start with since there's no agent to install or maintain. Alright, next question. Question 16. What is the difference between HTTP and HTTPS? Here's a strong way to approach it. HTTP transmits data in plain text between client and server. HTTPS is HTTP layered over TLS or SSL, which encrypts that traffic and verifies the server's identity via a certificate, protecting against eavesdropping and man-in-the-middle attacks. Let's keep going. Question 17. What is a REST API? Here's a strong way to approach it. A REST API is a web service interface that uses standard HTTP methods, GET, POST, PUT, DELETE, on resource-based URLs to let clients create, read, update, and delete data over HTTP. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.